Statistics, paper 31, advanced level, mathematics, Friday, 14 June 2019. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. The total mark for this part of the examination is 50. Question number 1. 3 bags A, B, and C each contain 1 red marble and some green marbles. So part A says draw a tree diagram to represent this information. So to draw the tree diagram, you have the branches, 2 branches. The probability of getting a green is 9/10, and the probability of getting a red is 1/10. So if you pick a red the first time, you stop. So for the first pick, if you look at that column there, the first pick, if you pick a red, everything stops. But if you pick a green, you go ahead and do a second pick. And in the second pick, if you pick a red, you stop. In the second pick, if you pick a red, you stop. Or if you pick a green, you go ahead to do the third pick. In the third pick, if you pick a green, okay, and if you pick a red, you stop. So the 3 picks, 1, 2, 3. You stop if you pick a red. If you pick a green, you go ahead. If you pick a red, you stop. If you pick a green, you go ahead until you get 3. And in bag A, there's 1 red and 9 green. So total in bag A is 1 plus 9 is 10. In bag B, there's 1 red and 4 green. So the total is 1 plus 4 is 5. And in bag C, there's 1 red and 2 green. The total is 3. Question 1b. Find the probability that Sasha selects 3 green marbles. So probability of green, green, or green. So what happens is the first time, if you select a green, the probability is 9/10. Select a green the second time, the probability is 4/5. And the third time is 2/3. And as you go along the branch, you multiply them. So probability of green, green, and green is 9/10 to get green the first time, times 4/5 to get green the second time, and times 2/3 to pick green the third time. And you multiply them, it gives you 12/25, which is 48%. Part C, find the probability that Sasha selects at least 1 marble of each color. So what you can do is the first pick, the second pick, and the third pick. So I can pick green and red, or you can pick the green and a red there, because you want to pick at least one of the colors. So this is another way to look at it. You want to have at least one of each color. So what you do not want, you don't want to have green, 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 or first time pick red. So you do not want to pick red the first time and the experiment ends, and you don't want to pick green, green, green. They're all the same color. Green, 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 they're all the same color. Or if you pick red, it's just one the same color. So you don't want those two options. Picking red, it ends. Pick green, green, green is what you don't want. You want at least one of each color. So let's find out what probability of green, 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 or red is. Probability of green, green, green is 0.48, which we got from the previous part of the question, which is 12/25. The green, green, and green. Probability of the red is 1/10, which is 0.1. So you add the two together, you get 29/50 or 0.58. So probability of at least 1 red and green is 1 minus that 0.58. It gives you 0.42. So you subtract from 1 and you get the probability of at least 1 red or green. Part D, given that Sasha selects a red marble, find the probability that he selects it from bag B. So if we use this conditional probability of A given B is probability of B intersection A over probability of A. So arrow B means from the red back, select from red marble from the back. And so now what you want to do is you either want to select the yellow one here, which I've put in yellow color. You want to have a red, or you want to have a green and then a red, or you want to have a green, and a red. So given that Sasha selects a red marble, find the probability that he selects it from bag B. So you can have a red, or a green and a red, or a green, and a red. So arrow B means probability of getting a red from bag B. So the way I look at it is probability of getting a red from bag B intersection probability of a red. So a red from bag B is part of all the reds. So this top one, probability of getting a red from bag B intersection probability of getting a red, is just the same as probability of getting a red in bag B divided by probability of a red. Now, what's the probability of getting a red? We can do 1 over 10 plus a green and a red, probability of a green times probability of a red, plus probability of a green times probability of a green times probability of a red. And when you do all of that, you get 0.52, which is 52%. That's one way to do it. Another way is to find, this is another way to do it. Another way to get probability of red is 1 minus the probability of green. So 1 minus 0.48, which gives you 0.52. So that's another way to do it. So the answer 52% or 0.52 is the same as this 0.52. So there's two ways to do it for that part C. So the probability of red from bag B is 9 over 10 times 1 over 5. 9 over 10 times 1 over 5. It gives you 9 over 50, which is 0.18. So now your probability of red from bag B, given that it is red, is the probability of red from bag B divided by the probability of red. So it's this 0.18 divided by the 0.52. And that will give you 9 over 26 or 0.346. If you change to percentage, 34.6% or 9 over 26. That's question 1A. That's question 1B, C, and D. That's another way to do question 1C. And that's another way to do question 1D. Question number 2. The partially completed box plot in figure 1 shows the distribution of daily mean air temperatures using the data from the large data set for Beijing in 2015. And they've defined an outlier. Part A, complete the box plot in figure 1 showing clearly any outliers. So for question 2A, that's what a box plot looks like. You have an outlier. It can be at this end. You can have an outlier at the other end. You have a minimum value. You have a maximum value. You have the interquartile range, which is the lower quarter difference between lower quarter and upper quarter. And then you have the median. So the minimum value is, you can use this for it, the Q1 minus 1.5 interquartile range. And then the maximum value. So we want to find out these values from those data. And they've given us that outlier is defined using 1.5 times interquartile range below Q1, which is similar to that. And this one is similar to that. That's what we're going to use. So reading information from the graph, you will see the lower quartile there is 19.4. This is divided into 0.2, 0.4, 0.6, 0.8. So it goes up in 0.2. So this is lower quartile is 19.4. The next one you need to get is the upper quartile. Upper quartile is 26.6, 0.2, 0.4, 0.6. The upper quartile is 26.6. Lower quartile is 19.4. That's what we need. And then we need to work out interquartile range, which is upper quartile minus lower quartile. So 26.6 minus 19.4. So the interquartile range is 7.2. Now we've got three important things. Interquartile range 7.2, lower quartile 19.6, upper quartile 26.6. So we want to find a value which is greater than Q3 plus K bracket Q3 minus Q1. Upper quartile is the Q3, K is 1.5, interquartile range is 7.2. If we put that in our calculator, we get 37.4. So anything above 37.4 is an outlier. And we do the same for anything less than Q1. Lower quartile is 19.4, K is 1.5, interquartile range is 7.2, and that gives us 8.6. So that's 8.6. Any number below 8.6 is an outlier. And since the three lowest temperatures are 7.8, 8.1, 9.1, outliers are the ones which are below 8.6. So 7.6 and 8.1 will be the outliers. So if we plot it on that graph now, we will use 8.6 as the minimum point. I've zoomed in here for you to see it clearly. So that point there, the minimum point 8.6, that's where we plot that. And the numbers below 8.1, 8.1, 7.6 are outlier. And that's 8.1 there, that's 8. And that will be 8.1 there. And then 7.6, that's 7.2, 7.4, 7.6. 7.6 is an outlier. 8.1 is an outlier. So I've just zoomed in so you can see what is drawn there. That's what has been plotted there. Question 2b. Using your knowledge of the large data set, suggest from which month the two outliers are likely to have come from. The month is October. Why? Since it is the month with the coldest temperatures between May and October. So between May and October in Beijing, October is the coldest month. And how do we know that? It is autumn in the northern hemisphere. So say, for example, autumn for 2021 in the northern hemisphere will begin on Thursday, 23rd September and ends on Tuesday, 21st December. So October is in the middle there. So October is in the middle there. And all days are in standard China standard time. So since October is in the middle there, it's autumn time, and that will be the cold time. So that's why we chose the month of October. And Beijing is in China and it's in the northern hemisphere. Using the data from the large data set, Simon produced the following summary statistics for the daily mean air temperatures, X degrees for Beijing in 2015. N, sum of X and SXX. Show to three significant figures the standard deviation. This is the formula for the standard deviation. And we have to choose the correct one to use. We look at the information. We are given SXX and we are given N. So we use those two. So we're going to use this last one. So we'll substitute SXX in there. So substitute SXX in there. And then we substitute 184 in there. Put it in your calculator. You get 5.19 degrees Celsius to 3 significant figures. QED, quod erat demonstratum, as required to show, because it said we should show it. So this is Latin, means we have shown it. Simon decides to model the air temperatures with a random variable. T is a normal distribution. Use Simons's model, calculate the 10th to the 90th percentile interpercentile range. So interpercentile range is the difference between the values for two given percentiles. That's what it is, the difference between the values two given percentile. So the 10th to 90th percent interpercentile range is often used since it is not affected by extreme values, but still considers 80% of the data in its calculation. So looking at this as a normal distribution, the mean is 22.6. Standard deviation is 5.19. And we are using, if we start with the 90th, so we use 0.9 for percentile, and we'll do it in the calculator. So we want the area to the left. So we would put a tail on the left. The area is 0.9. Standard deviation is 5.19. And the mean is 22.6. And then using the inverse normal distribution, it will give us 29.2512526. And we do the same for 0.1, the 10 percentile. So the standard deviation stays the same, 5.1. The mean stays the same, but we'll go to 10 percentile now, and that gives us 15.948. So now we want to find the interpercentile range. So we subtract them. 29.251 minus 15.94. That gives you the 10th to 90th interpercentile range to be 13.303. Another way to do it on the graphics calculator is to put it in as inverse normal cumulative distribution. Inverse normal cumulative distribution. The 0.9 represents the 90th percentile, 5.19 represents the standard deviation, 22.6 represents the mean. Make sure you put the commas. Minus inverse normal cumulative distribution. 0.1 is for the 10 percentile, 5.1 is for the standard deviation, and 22.6 is for the mean. And when you put them, don't forget there's a minus in the middle. You get 13.03, which you can see here. That's what I put in the calculator, and it gives you the answer. And you can also do it from getting the information from a table if you're not using a calculator. Simon wants to model another variable from the large data set for Beijing using a normal distribution. State two variables from the large data set for Beijing that are not suitable to be modeled by a normal distribution. So one of them, the daily wind speed on the Beaufort scale. Why? It is qualitative data or categorical. Also, rainfall is not symmetric. So there are lots of days with zero rainfall. So this is just to help you. If you look at the Beaufort wind scale, it gives things like calm, light air, light breeze, gentle. And you will have calm, light air, light breeze, gentle. So these are qualitative data or categorical. So that is why it wouldn't represent it in a normal distribution. And to get symmetric for normal distribution, where the left side and the right side, where the mean, median, and mode is in the middle, rainfall would have too many days without rain, so the data would not be symmetric. And that's what symmetric will look like. So an example of something that will be symmetric, distribution of male heights. This will be symmetric. but the rainfall will not be.